So we're going to gradually, over the next decades, push our human exploration beyond the boundaries as our robotic explorers find out new things about what's interesting out there.
When humans go back to the moon, they will almost certainly be traveling in vehicles that look very similar to the Apollo spacecraft of the past. These next-generation vehicles will use an improved large blunt body capsule that will have more than 3 times the volume of the Apollo capsules. Coming up, we'll look back at the beginning of the Space Shuttle program. But first, did you know that one major difference being planned for next-generation missions to the moon will be the number of crew members on the surface of the moon? During the Apollo program, only 2 crew members would take the lander down to the surface, while 1 crew member stayed in lunar orbit to maintain the ship. The new system will allow a 4-member crew to transfer to the lunar surface, while automated systems will maintain the crew spacecraft in orbit.
Towards the end of the Apollo program, NASA officials were already thinking about what would be next for the American space program. At that time, the rockets used to place astronauts and equipment into space were designed to be used only once. Although effective, NASA planners decided that they needed a system that was less expensive, reliable, and perhaps most of all, reusable. The idea of a reusable space shuttle that could launch like a rocket and land like an airplane was appealing, and would soon change the way astronauts were traveling into space. The space shuttle was born on January 5, 1972, when President Richard Nixon authorized the development of reusable vehicles for space exploration. The project became known officially as the Space Transportation System, or STS. It was based on a piloted spacecraft boosted into orbit by a reusable launch vehicle that could return to Earth like an airplane, ready to be used again on short notice. This new vehicle consisted of 3 primary elements: a delta-winged orbiter spacecraft, 2 solid rocket boosters, and 1 external fuel tank. Over a 10-year span, 5 orbiters were built, including the test vehicle named Enterprise, and the 4 space orbiters, Columbia, Discovery, Atlantis, and Challenger. On April 12, 1981, after years of testing and construction, the first shuttle, Columbia, reached orbit piloted by astronauts John Young and Robert Crippen. The first 4 shuttle flights were collectively called the Orbital Flight Test Program and demonstrated how the spacecraft performed under real spaceflight conditions. During these first 4 flights, NASA tested the shuttle as a launch vehicle, habitat for crew members, freight handler, instrument platform, and aircraft. After the 4th landing, NASA declared the shuttle ready for operation. Since that time, the shuttle program has performed well over 100 missions and has accomplished a number of monumental achievements. In June 1983, Sally Ride became the first American woman in space. The shuttle launched the Magellan spacecraft to Venus, the Galileo spacecraft to Jupiter, and the Ulysses spacecraft to study the Sun. The shuttle also has deployed the Hubble Space Telescope, the Gamma Ray Observatory, and the Upper Atmosphere Research Satellite. Another key milestone came in 1998 when astronaut John Glenn, the first American to orbit the Earth, returned as the oldest man ever to reach space as a member of the crew of Discovery on a 9-day mission. The shuttle has also been instrumental in constructing and outfitting the International Space Station, while also being used to carry large payloads to and from orbit and perform servicing missions on satellites. The design, now approaching its 3rd decade, is still state-of-the-art in many areas, including computerized flight control, airframe design, electrical power systems, thermal protection system, and main engines. Even though the sophisticated shuttle program suffered the devastating losses of the Columbia and the Challenger, its successful missions have made great strides in space travel and exploration during its short history. More than 100 documented NASA technologies from the space shuttle are now incorporated into the tools we use, the foods we eat, and the biotechnology and medicines used to improve health. Although plans are now in the works to retire the fleet, the Space Shuttle program will forever hold a special place in the history of space travel, not only for its unique design, but for the history and technologies it brought to all of us.
Even though the space shuttle will eventually be phased out, NASA planners still hope to use the proven shuttle main engine and booster technology on next-generation vehicles. Our final story focuses on the advent of GPS. In recent years, the GPS receiver has been one of the most useful tools for professional pilots, drivers, and seafarers. These receivers use geospatial data to identify geographic locations and characteristics of natural and man-made features on the Earth.
These receivers are also being used by hikers, golfers, and fishermen for recreation purposes. However, many people who use this technology still don't know exactly how it works.
Our Johnny Alonso finds out how this complex system helps keep many of us on track and on schedule.
Trying to figure out where you are and where you're going has always been a challenge. Navigation and positioning are crucial to so many activities, and yet the process has not always been easy. Thankfully, the days of navigating by celestial means or landmarks are long gone since the introduction of GPS, or the Global Positioning System. So what is GPS? For some answers, I spoke with Dr. Kevin Dutton at NASA Langley to find out how it works.
GPS stands for the Global Positioning System, and like the name suggests, it's a system to find your location anywhere on the Earth or near the Earth's surface. And the way it does that is by using radio frequency broadcasts from orbiting satellites.
Can you tell me why GPS was originally developed?
It was developed by the Defense Department to meet all of their navigational needs. For example, aircraft and ships at sea. And now even individual soldiers carry little receivers like this in the field to find out where they are.
The Global Positioning System consists of a constellation of 24 satellites and their ground stations working together. GPS uses these man-made stars as reference points to calculate positions accurate to a matter of meters, and in some cases centimeters. As long as you have a GPS receiver and a clear view of the sky and a map, you'll never be lost again. Today, GPS is finding its way into cars, boats, planes, construction equipment, farm machinery, even laptop computers. So how does the system work?
Let's say you're backpacking and you have a receiver with you. You're going to turn on that receiver. Now the GPS satellites are constantly broadcasting a signal, all 24 of them, but above you at any one time there's only 12 available, and then the other 12 are on the other side of the Earth.
Okay.
So your receiver is going to listen and try to find at least 4 of these satellites directly above you, and then it's going to determine a range to each satellite, and it's going to use those ranges and the known locations of the satellites, and it's going to do some mathematical calculations and a process called trilateration, and it's going to figure out where that GPS receiver is. That'll also give you altitude, and it'll give you speed and the direction that you're traveling in.
A standard GPS receiver will not only place you on a map at any particular location, but will also trace your path across a map as you move. If you leave your receiver on, it can stay in constant communication with GPS satellites to see how your location is changing. With this information and its built-in clock, the receiver can give you several pieces of valuable information like how far you've traveled, how long you've been traveling, your current speed and your average speed. Also, the estimated time of arrival at your destination if you maintain your current speed.
There's a lot of uses that they hadn't really thought about when they developed the system. For example, later on it was discovered that if you put multiple antennas on a vehicle, like an aircraft for instance, you could actually get attitude. You could figure out its orientation and whether it was rolling or pitching or yawing. Other things that they didn't realize they could really do were, for instance, seismologists use it for earthquake detection and to find out when tectonic plates are actually shifting apart. It's that good.
Something else.
Yeah, very interesting.
Sure. So that's how it works. So the next time you want to know where you are or where you're going, don't reach for a map. Reach for your GPS. Now, which button is it here to press for a date for tonight's gathering?
That's all for this edition of NASA's Destination Tomorrow. Thanks for joining us. I'm Steele McGonigal.
And I'm Kara O'Brien. For all of us here at NASA, we'll see you next time.